Chemical properties of carbon compounds. The first reaction that we are going to see is combustion reaction. Combustion means burning in air, that is reaction with oxygen. So general reaction, any carbon compound, when it burns in oxygen, it produces carbon dioxide, water vapor along with heat and light. If only carbon is there, water vapor will not be generated. So the simplest combustion reaction is C plus O2, that is carbon when burnt in oxygen will produce carbon dioxide, gas, carbon solid, oxygen gas will give you carbon dioxide gas along with heat and light. Now this carbon can be coal, graphite, or even it can be diamond. Diamond at 800 degrees centigrade will catch fire and will produce carbon dioxide. So this is the first combustion reaction. If we have a hydrocarbon instead of the carbon, for example, this is natural gas which is present in CNG, and it is methane CH4. When it burns in air, that means react with oxygen in air, produces two products. One is carbon dioxide gas along with water vapor H2O, again gas along with heat and light. So see, all these reactions are exothermic because energy is given out in all these reactions. So all these substances are used as fuels. For example, CNG is used in vehicles or for the production of electricity. Here this reaction is not balanced, so we have to balance it. There are 4 hydrogen on the reactant side. So to make 4 hydrogen on the product side, we have to write 2 here. Then that will make number of oxygens 2 plus 2 4, so we have to write 2O2 here. So this is the balanced reaction. Like methane, ethanol also burns in air, CH3CH2OH. This is nothing but ethanol, alcohol with 2 carbon atoms. This is also used as a fuel. This is liquid. This is also used in vehicles as an additive fuel. Again, it gives the same products, carbon dioxide and water vapor. So CO2 gas plus H2O gas along with heat and light. We need to balance it. So there are 2 carbons on the reactant side, so we have to make it 2 here, and there are 6 hydrogens, 3 plus 2 plus 1, 6, so we have to make it 3 here. So in all we have 3 plus 4, 7 oxygen. Out of this 1 oxygen is here, so 6 oxygen remaining. So you have to write it 3 over here. So this is how you balance the reaction. These are the combustion reaction. Now in combustion reaction you have to remember that if we have got saturated hydrocarbon, that means single bond, then all the saturated hydrocarbon, they burn with a clean blue flame without any soot. But if you have unsaturated hydrocarbon, then they burn with a yellow flame along with soot. Soot is nothing but smoke particles, that is unburnt carbon particles. So the decomposition occurs because unsaturated hydrocarbon, they contain more amount of carbon than hydrogen. So they burn with sooty yellow flame. If sufficient air is not available, then even saturated hydrocarbon will also produce smoke. So this is combustion reaction. Combustion reaction is also oxidation reaction. Because the reactants combine with oxygen here. They are also exothermic reaction because heat and light is released in this reaction. So all these are the fuels, like coal is a fuel, methane gas CNG is a fuel, then ethanol is a fuel. Similarly, gases like propane, butane and higher hydrocarbons all are used as fuel. There is one more reaction, oxidation reaction. And this oxidation reaction is different from the combustion reaction. So by definition, oxidation is combining with oxygen. So in this reaction, the reactants combine with oxygen, but they do not burn. In this reaction, alcohols are converted into acids. For example, we have an alcohol CH3CH2OH, ethanol, and the conditions of the reactions are you have to use the oxidizing agent, which actually provide the nascent oxygen. So we write oxygen in the square bracket, indicating the nascent or atomic oxygen. Now, which substances can provide this nascent oxygen? There are oxidizing agents like alkaline potassium permanganate or acidic potassium dichromate along with heat. So when ethanol is heated in presence of oxidizing agents such as alkaline potassium permanganate or acidified potassium dichromate, alcohol is oxidized into acid. See what happens in this reaction. So you have to understand the mechanism of the reaction, then it will be easier for you to remember the product. So this hydrogen, these two hydrogens, they are removed from the reactants. So you can see say that this is removal of hydrogen, which is also a definition of oxidation, and instead of that oxygen added. So addition of oxygen also take place in there. So what will happen if this happens? That means two hydrogen are removed, so two valencies become unfulfilled, and to fulfill these valencies we have carbon oxygen double bond in that. So it is CO. This OH remains as it is. So CH3COOH. So if you look at the product, it will be ethanoic acid. And you will see that these two hydrogens along with one more atomic oxygen will produce water. So this is the reaction in which alcohols are converted into acids, and this is addition of oxygen, removal of hydrogen. So in all, you can write the reaction as alcohol plus nascent oxygen gives you carboxylic acid plus water. So this is a general oxidation reaction, oxidation of alcohol. So we have seen combustion, we have seen oxidation. The next reaction is addition reaction. Now addition reaction in this carbon compound is similar to the combination reaction of inorganic substances, inorganic compounds. So in combination reaction, you know that two or more reactants combine together to form a single product. Here also, two reactants, they combine to form a single product. Like we have an unsaturated hydrocarbon with, let us say, carbon-carbon double bond in between. So you have a reactant like this. This is any unsaturated hydrocarbon. R stands for any alkyl or other group, unsaturated hydrocarbon. So what is added into this? A hydrogen can be added to this. Obviously some catalyst is needed here, and in this case nickel catalyst is there. So when unsaturated hydrocarbons are reacted with hydrogen in presence of nickel catalyst, what happens? These two hydrogens are attached to these carbon atoms, and this double bond is converted into single bond. So when double bond is converted into single bond, one valency of carbon is unfulfilled, which is fulfilled by the hydrogen gas, like this, and the remaining alkyl radicals, they are intact, they do not change, but only this double bond is converted into single bond and two hydrogens are added to this. So this is addition reaction. So unsaturated hydrocarbon is converted into saturated hydrocarbons in a addition reaction. In an addition reaction, unsaturated hydrocarbon is converted into saturated hydrocarbon. So this reaction is used in hydrogenation of vegetable oils. Hydrogenation means addition of hydrogen of vegetable oils. Obviously, vegetable oils are unsaturated compounds, and when they undergo hydrogenation, they give you saturated compounds, and that is vegetable ghee, as we call them as. So this reaction is addition reaction. Next reaction of carbon compounds is substitution reaction. And substitution reaction is similar to the displacement reaction of inorganic compounds. We know that in a displacement reaction, a single atom or ion which is more reactive displaces other atom or ion. Here alkanes like methane, when they are reacted with halogens like chlorine in presence of sunlight, such type of reaction takes place. Now generally saturated hydrocarbons are non-reactive because they contain all the single bonds, but halogens are exception. Halogens can displace hydrogen one by one from the alkane. So what happens in this reaction? One of the hydrogen is replaced by chlorine, so it becomes CH3Cl, and that hydrogen combines with chlorine to form hydrogen chloride gas, and it gives rise to chloromethane. Now the reaction can continue, and there is replacement of hydrogen atom one by one. So this chloromethane in presence of sunlight combines with chlorine to form CH2Cl2, obviously along with hydrogen chloride gas. So this is dichloromethane, and the reaction continues further, like CH2Cl2 reacts with chlorine in presence of sunlight to give CHCl3 plus HCl. So this is nothing but trichloromethane, and finally CHCl3, again it combines with chlorine to ultimately give you CCl4, that is tetrachloromethane, along with hydrogen chloride gas. So this reaction, it takes place step by step, and one by one all the hydrogens are replaced by halogen, in this case chlorine. So these were the reactions of carbon compounds. We'll revise them once again. First was the combustion reaction, in which hydrocarbons burn in air, react with oxygen to produce carbon dioxide, water vapor, heat and light. Then there was oxidation reaction, in which alcohols combine with nascent oxygen to give you carboxylic acids and water. We have addition reaction, in which unsaturated hydrocarbons combine with hydrogen. They also can combine with halogen here, chlorine and bromine. Similar reaction takes place. So in place of hydrogen, there can be chlorine or there can be bromine. So this is addition reaction. Then we saw substitution reaction, in which hydrogens in alkanes are replaced by halogen one by one. Now there are some more reactions and they are specific to certain compounds. So first there is reaction of means ethanol. So we can say that chemical properties of ethanol. So we know that ethanol, CH3CH2OH, is an organic compound which is industrially important compound. It can be used as fuel. It is used in medicines as a solvent. In tincture iodine, again it is used as solvent of iodine, and a mixture of iodine and alcohol is used as a disinfectant. So here we are seeing the chemical properties of ethanol. The first property is the ethanol, that is CH2OH, can combine with sodium metal. Now whenever sodium metal appears in the reaction, you have to understand that this is highly electropositive. And electropositive sodium atoms, they have very high affinity towards electronegative atom like oxygen. So what this will do in this reaction, it will remove hydrogen and take its place. So this simple reaction, CH3CH2O and sodium will be attached. It will remove hydrogen from that. So hydrogen will be released in form of hydrogen gas. So to balance it, you have to write 2 everywhere. So the compound is formed here. It is called sodium ethoxide. This compound is sodium ethoxide. You can see the structure here. It is CH3, CH2. That means the first carbon has 3 hydrogen. Second carbon has 2 hydrogen. There is a single bond over here. Oxygen is attached, and the second valency of oxygen is fulfilled by nitrogen. So this radical, this is called ethoxide radical. So the compound is called sodium ethoxide. So ethanol or any other alcohol for that matter, when reacted with sodium, gives rise to sodium alkoxide. Here sodium ethoxide, sodium alkoxide along with hydrogen gas. So this is reaction with sodium. So you can label it as reaction with sodium. The second reaction, we are seeing the reactions of ethanol, is dehydration reaction. Dehydration reaction. By the name dehydration, you know that dehydration, that means removal of water. So water can be removed from alcohol. If you write the structure, it will be easier to understand the mechanism of the reaction. In examination, you need not write this in the structural form. You can just write CH3CH2OH. That will do. So dehydration, now dehydration takes place in presence of dehydrating agent, and dehydrating agent is hot concentrated sulfuric acid. Just as we have seen the oxidizing agent which provides nascent oxygen, and that was alkaline KMnO4 or acidified K2Cr2O7. Here sulfuric acid acts as a dehydrating agent. Dehydrating agent. That means it removes water from this. So what is the result of the reaction? It removes this OH and this H. So what happens here? You can see one valency of each carbon atom becomes unfulfilled. So that is fulfilled by a double bond afterwards. So CH2, this hydrogen is removed. So one valency, and for this OH is removed. So one more valency. So CH2 double bond CH2. So you can see that the ethanol is converted into ethene. Ethanol is converted into ethene along with obviously water. That's why dehydration reaction, removal of water. So how can you remember? Hot concentrated sulfuric acid is dehydrating agent. So you have to remember like this: if hot concentrated sulfuric acid is used, it will remove water from alcohol and it will then produce an alkene. So general reaction, you can say that the alcohol is converted into alkene along with water, and that's why it is a dehydrating reaction. Dehydrating agent is sulfuric acid. So then the next reaction is chemical properties of ethanoic acid. So these two reactions were chemical properties of alcohol, reaction with sodium metal, and dehydration reaction. Now the chemical properties of ethanoic acid or acetic acid, which is commonly known as vinegar when it is mixed with water. It's an organic acid, so it shows all chemical properties of acid. Properties of ethanoic acid. As we have seen, it's an organic acid. So again the reaction with sodium, it can take place like CH3COOH. This is organic acid, it can react with sodium. Again we have seen that sodium has very high affinity towards oxygen, so it will remove hydrogen from this and this will give rise to CH3COONA. If you want to write the structure, you can write it like this: CH3CO and ONA. Now we have seen the ethoxide radical. Here it is ethanoate radical, so alkanoate. So this is sodium ethanoate, CH3COO is sodium ethanoate, and along with that hydrogen gas is released. Now this reaction is a similar reaction to any acids, means many acids, they react with metals to give rise to a salt and hydrogen gas. So this is among those reactions. Now see the difference between the two salts. This is sodium ethanoate, which is prepared when an organic acid reacts with sodium, and when alcohols react with sodium, we have seen a different product, and that was sodium ethoxide. Here you can see sodium ethoxide, CH3CH2ONA, CH3CH2ONA. So this was an alkanoate radical, alkoxide radical, and what we have formed here is alkanoate radical. Now there is one more reaction in which alcohol and acid, they combine to give sweet smelling substance called ester. So if we have an alcohol like CH3CH2OH, so this is nothing but an alcohol ethanol, is reacted with organic acid like ethanoic acid. Here let us say CH3COOH. So this is ethanoic acid. Reaction takes place in presence of sulfuric acid or any other acid for that matter, that means H plus ion. See what happens in this reaction. In this reaction, acid easily loses hydrogen and alcohol loses OH radical. So when H and OH radical, they combine together, obviously they will form water. But what happens to the remaining carbons. This CH3COO, this CH3, we are talking about this CH3, C double bond O, single bond O. Now this one valency of oxygen is unfulfilled, which is fulfilled by this alkyl group. So it combines here like CH2, CH3. And this is ester. This is a sweet smelling substance. It's an ingredient of many fruits and flowers, not this ester, some other ester. So how can we name it? Now this is, as we have seen here, CH3COO is nothing but our alkanoate radical, and this is your alkyl radical. So here both are having two carbons. So this ester is named as ethyl ethanoate. This is ethyl ethanoate. Correct. So acid will always give the alkanoate. Acid will always give the alkanoate part of ester, and alcohol will always give alkyl part of the ester. So suppose you have to prepare another ester like propyl butanoate, for that matter, propyl butanoate, then alcohol part is giving alkyl, so you have to use propanol, and acid gives the alkanoate part, so you have to react it with butanoic acid. So like this you can remember कि alcohol always gives alkyl part and carboxylic acid alkanoate part in any esterification reaction. Now the reverse of this reaction is called saponification reaction. Saponification reaction is used in making soaps. So esterification, have you written the heading here? No, we have to write the heading, that is, this is esterification, that means production of ester, and opposite reaction is saponification reaction. Saponification. In the saponification reaction, ester is reacted in presence of sodium hydroxide. So the same ester, you can write it in a shorter, at CH3 COO CH2 CH3. When it is reacted with sodium hydroxide, again we know that sodium has very high affinity towards oxygen, so it will remove this alkyl part there, give rise to CH3COONA, and this is very familiar salt now, sodium ethanoate, and alkyl part will combine with hydroxide radical to give you alcohol. So it gives back ethanol, and this is sodium ethanoate. So ester, that is ethyl ethanoate, in presence of sodium hydroxide give sodium alkanoate. Now if this is a very long chain carboxylic acid of sodium or potassium salt, they are used as soap. So that's why the reaction is known as saponification reaction. So when this chain is very long and we have sodium or potassium over here, that compound is called soap. Now there are two more simple reactions which are actually the characteristic reactions of acid, and one of them is neutralization reaction. CH3COOH, we'll write the heading, neutralization. Acid reacts with a base, so it reacts with sodium hydroxide to give salt and water. So it gives you CH3COONA, same compound, sodium ethanoate, plus H2O. So this is simple neutralization reaction where acid combines with base to form salt and water. Similarly, the reaction with metal carbonates like acid CH3COOH when combines with carbonate Na2CO3, again it gives you salt, carbon dioxide and water. So again salt is CH3COONA, same salt, sodium ethanoate, along with carbon dioxide and water. So I had 2 sodium over here, so you have to write 2 here and 2 here, so that will balance. Again the same products will be obtained if it is reacted with sodium hydrogen carbonate. In this case the products will be same, CH3COONA along with carbon dioxide and water. So this is reaction with metal carbonates or hydrogen carbonates. So these are the chemical reactions of carbon compounds. In all, we can count how many reactions are there. First was combustion reaction. You can write 1 over here. All these 3 reactions are for combustion. Second was oxidation reaction. Third was addition reaction. Then substitution reaction. These 4 reactions were the common reactions of carbon compound. Then chemical properties of ethanol. In that sodium reaction with sodium was 5th one. Dehydration, sulphuric acid, dehydrating agent. Then properties of ethanoic acid, reaction with sodium, 7th one. Esterification, 8th one. Saponification, 9th one. Neutralization, 10th one. And reaction with metal carbonate, hydrogen carbonate, 11th one. So only these 11 reactions are there. If you remember the mechanism of these reactions, then it is very easy to write all these reactions. And even if the reactants are changed, means number of carbon atoms are changed, the reactions remain the same, because all the members of homologous family, they show similar chemical properties. So it is very important to remember the mechanisms of the reactions.